It's really great to see you. Wow. I'm really excited here. I want to thank Matthias and his staff for giving me this opportunity to come talk to you. I know that I'm in a very tough spot here. I'm between you and lunch, so I will do my best to fit within my 30 minutes and make it as entertaining and as informational as possible. I did have a demo prepared, but I think for this 30 minutes, I think I'll be able to just talk my way through it. So, once again, it's awesome to be here and to see how this conference is growing. My talk today, and my name, or before I get into the talk, is Marius Pana. I represent Spearhead Systems. We're an IT service provider located in Bucharest, in Romania, and we are highly focused and specialized on CheckMK monitoring. My talk today is based on a request and also something that we noticed internally with our own larger customers. People are starting to put an accent on making CheckMK highly available. And so we've been tasked by some of our customers to put up clusters to figure out ways to make it highly available, and it just fit in with the request from the CheckMK team. So that's what we're going to be talking about today. Hopefully it'll be something that you can take home with you and use it in your own high availability projects. So, it's with really great pleasure to say that CheckMK is important. It's become a very important tool in all of our projects because it gives us perspective. So the monitoring information that we get basically gives us what I call insight and visibility. Or I think I took this off some other monitoring product way back in the day, but it does give you this insight and visibility. By insight, I'm specifically talking about the trending and historical information that you can take a look at, and that helps you make business decisions. You no longer have to shoot in the dark. You can literally look at the reports and the graphics that CheckMK gives you, and you know how to do your capacity planning, how to budget for your systems next year. If you get a little bit more advanced and you use the business intelligence functionality, then you can do really amazing things such as what-if analysis. And these are obviously great for us, the technical people that get to sit and play with these things, but they offer very valuable information to the business side. And this is what's been surprising for me as I've been growing from systems engineer, technical type of guy, more into a commercial and sales type of role, is the impact that these tools have on the business side of things. And we're talking about global customers that are now relying on information and reports that we get from CheckMK. So that's why we think, and we know, and it's evident because we're all here, that CheckMK is important and it's becoming more and more important. Another aspect that's important is the fault management. Any monitoring solution that is worth anything has to do some form of fault management. CheckMK, through the use of its rules, makes this very easy, and you can do complex things with it. You don't just catch the fault and say, here it is, we found it. You can manage the life cycle of it through advanced rule sets, through integration with event management systems, CMDB systems. So you can literally manage the entire life cycle of a fault, which is also, once again, good for us technical people, but it's great for the business because we can automate a lot of that process. And what all of this boils down to is business continuity. We all want to make sure that these systems, specifically CheckMK, is highly available or reaches this concept of business continuity. Business continuity, what it boils down to is actually quite simple. It's basically assuring that your end users have access to your system with as little to no downtime if possible. So that's going to be the focus of our short talk today. Before I get into the nitty-gritty details, I want to present some terminology. Now, this is a standard terminology when we're talking about business continuity processes, but I've sort of cherry-picked what I feel is relevant for this particular case. The end game is to make our system highly available, which falls under the umbrella of business continuity. Business continuity is a huge subject. If you just check out the Wikipedia page and you see how many links it forks out to, you'll understand that it is a fairly complex concept, but I'll focus on just three components of it, actually just two components of it today. The first one is fault tolerance. This means handling a fault one way or another. Specifically with CheckMK, and the high availability options we'll be looking at, we're looking at handling hardware faults. So if a server or a hard disk or something within it fails, we have a backup solution that can take over, hopefully on the fly, very quickly. One concept under business continuity is this continuous availability. And as I talk to more and more business owners, I'm starting to understand that they have a very different view of what high availability means. When they talk about highly available systems, usually they imply continuous availability. Continuous availability, as the name implies, is 100% uptime, continuously available. And these are complex systems. Sometimes they require the re-architecting of the software so that they can be continuously available. And this is specifically what I'm not going to talk about. But it is important to know that you can achieve this. It is expensive, and it most likely requires re-architecturing at least some of the software components so that they can be made continuously available. It's not common for a monitoring solution to be continuously available, not an IT monitoring solution. Life support systems from doctors, those are continuously available. Some aerospace technology is continuously available. Stuff running in nuclear power plants, those are continuously available. And we want those systems to be built that way. What we're going to talk about is high availability. And as the name implies, high or highly available means that it just needs to be above average or somewhat above average of availability. The secret to understanding high availability is that you decide, or your business or your product owner, project owner decides what the high availability level should be. And this is something that we specify. I think we've all heard the famous 5 nines. I get shivers when I look at this table because all of the projects in IT all of a sudden need the 5 nines, which gives you very little downtime to play with. That's 5 minutes per year. There's not much you can do in that 5 minutes per year. So the first step that you need to decide when you are tasked with making CheckMK highly available is, what is your SLA level? SLA levels, or high availability levels in this case, are expressed as a percentage of uptime, usually in a year. But what's interesting about this table is, I think we can all agree that 99.95, which is a 3.5 nines, is decent uptime. That's really good uptime. That means you've got 4 hours of downtime per year. So it really depends on how much leg room you have to play with this downtime. Do you have enough downtime to be creative and find creative solutions to making CheckMK highly available? If you're working with the 5 nines, which has sort of become a standard, then you really don't have much wiggle room, and you need to look at more complex solutions. Or not necessarily, as we'll find out. So, what options do we have? And these are in no particular order. Virtualization, this is quick and easy. Virtualization is sort of a standard in almost all enterprise IT, enterprise companies, and you're usually using the enterprise version, meaning you have all the bells and whistles and the features that you'd expect from an expensive virtualization solution. For the technically inclined, you can do it yourself, roll up your sleeves, put your own cluster together. This gives you great flexibility, but it might give you some headaches. The CheckMK appliance, this is definitely in the spirit of the way that CheckMK works. It's streamlined. You don't have to know the details behind the clustering that's going on behind the scenes. Very seamless integration. You can go for a backup and restore solution. I know somebody laughed. Probably some of you are laughing internally, but remember, it really depends on your SLA. Do you have enough time to backup and restore? Then you don't need to look at clustering solutions. And some other solutions that I sort of handpicked from what I've been following along on the mailing list and some of my own projects from back in the day when I was a little bit younger. So, the first option, virtualization. This is definitely quick and easy, and there's a huge benefit to using this. It means that you have no specific or special configuration necessary of CheckMK. That's because the virtualization technology is already taking care of that for you. Now, if you're the same person, if you're managing the monitoring and the virtualization, then all of that falls on you, so you have to do all the work. But usually, the infrastructure for virtualization is already in place. You just pop your virtual machine, set up your CheckMK server as you would any single CheckMK server setup, and you're ready to go. So there's great benefits here that you can be quick and fast. The players in this market are many and varied. I think we all know the VMwares of the world. Red Hat has a decent virtualization product. There's plenty of Linux and completely free open source solutions out there. Surprisingly, Microsoft is also virtualizing Linux servers quite well now. So you have a lot of options to choose from the free to the expensive and very expensive. And the cool thing about this is that they all function exactly the same. Sure, their marketing tactics, their speed, their features might be different, but the concept is the same. And I did some really crude drawings here while on the plane to try to show this to you. This is a typical, let's say, high availability virtual machine setup. You've got two servers, which we call hypervisors, and they're running their virtual machines, which is composed of the virtual hardware, the operating system, and the application. In this case, it would be CheckMK. Now, the secret sauce here is this little shared storage here. This is what we call a central backing store for the virtual machines. And all that it does is it stores the actual data files from your virtual machine. The memory, which is the memory and the state, runs on each of the hypervisors. And when you have a fault, so let's say my server failed, the other hypervisor, through whatever technology or voodoo that it has running behind there, it will realize that the other node is offline, and it will basically restart or start your virtual machine. Now, this is an important concept because it starts it. It means that it was forcefully powered off when this server went offline. When this server went offline, it's like it lost its power. And it just starts over here because your virtual machine is actually living here. Now, there's a couple of considerations to have in mind here. Because your virtual machine was forcefully powered off, it might not be in the best of states, depending what it was doing when the virtual machine went off. It might also be found, and this happens to us quite a bit. We have virtual machines that haven't been rebooted or had a file system check in ages, and something like this happens, and you're wondering why after 15 minutes it's not come back up, and you log onto the console and you'll notice that it's sitting in a file system check asking you to press yes or some other interesting stuff. So there are some caveats here that you need to take into consideration. Run file system checks often and automatically. Don't wait for your systems to fail because you will lose time. Nobody thinks to look and see why it's not bringing up. There's also other considerations to have in mind, but these are usually taken care of by the guy that's taking care of the virtual infrastructure. Specifically, you have to have the same networks accessible to both hypervisors. This is a shared storage, fiber channel or SAS or maybe even via Ethernet. You have to have access to that. If for some reason you lose access to it during a failover, your virtual machine's not going to come back up. But these, like I said, are usually being taken care of the infrastructure guys, and this is just a quick, elegant solution for you to get your CheckMK highly available. And we recommend this usually to anybody that is heavily dependent on VMware. There is something that I don't know if I came up with this or I read this somewhere and it sounded so good and I sort of took it on as my own, but we'll see what happens. We've realized in some situations running your monitoring solution right inside of your critical infrastructure on a virtual platform is not always the best idea. As good as the VMwares and the Red Hats and all of these shared storages are, things break, things fail. And if your virtual infrastructure is gone, so has your CheckMK monitoring system. So we almost always and exclusively recommend that your virtualization is outside, your monitoring, is outside of your virtual infrastructure. So that when your virtual infrastructure goes down, and it probably will at one point, your monitoring system is sitting safely outside of that. And as another best practice that we're trying to implement to some of our customers, obviously the larger guys that have money and resources to implement these things, we're pushing them to isolate a monitoring network. So you have your VLANs for management and whatnot, we're asking for a dedicated network for monitoring as well, just so we can avoid stuff like this and being stuck in a weird state. So virtualization should definitely be your first option if you're using it. If you're a really big company, then you might consider using the appliance or something that doesn't sit right on top of your virtualization infrastructure. So the next one, and this was fun, and this is still fun, do-it-yourself clusters. These require some specialized know-how. You're not going to get away with following some tutorial. Or actually, you might get away with it, but when stuff breaks, it's going to be difficult. You have to spend some time up front understanding the tools, understanding the procedures, because it's not the same as starting up a single server. You have these abstraction layers, resource groups in pacemaker language, which require some specialized knowledge. Pacemaker seems to be the standard clustering solution. It's a really great piece of software. It supports two types of clusters, quote-rate clusters, which are basically based on a quorum, which means that all members have to vote before a decision is made. And these are the type of clusters that we've built with Pacemaker and CheckMK. This is what the CheckMK appliance uses natively. And Pacemaker is also the Red Hat clustering solution, the SUSE clustering solution. So it's battle tested, it's enterprise grade, and it will do what you want it to do. The other type of clusters that it supports are resource-based clusters. These are very complex, dynamic in nature. We've never attempted to make a CheckMK cluster based on dynamic clustering, just because I don't know how it would handle multi-master nodes running at the same time. But the quote-rate clusters are almost exclusively what we always need, even for the largest installations that we've done. And this basically boils down to having an active and a passive cluster. This is what a typical Pacemaker setup might look like. You've got two compute nodes. They're no longer hypervisor. These are systems running Linux directly on them. We've got DRBD, which we use to synchronize two disks across. We've got the concept of resources. Resources are basically your application dependencies. So let's say you have a virtual IP, it needs to move around. You define that as a resource. You define some rules on how that resource is moved. And when something goes wrong, let's say server fails, those resources will be just started up over there. Usually you lose 1 or 2 seconds. It's really a fast process. This is a more detailed graph of what it looks like. CoroSync is used for messaging. We used to use Heartbeat, but CoroSync 2. Whatever version is out now really does a great job, and it does a lot more than Heartbeat does. The resource manager is actually Pacemaker itself, and then on top of that you have the resources. DRBD is itself a resource of a Pacemaker cluster. You have your actual application, which in this case would be OMD. But please remember that those require some time spent studying. You can and you will get away with using any tutorial that you find on the internet, but when it breaks, and I can't stress enough, maybe it's because of my advancing age, but things break in IT, not having gone through the process of studying and understanding the language and the way that it defines these resources can be difficult. So I talked about backup and restore, and I personally use this for our company who uses the managed services edition to monitor on behalf of our customers. And I was able to negotiate with some fairly large customers a 99.9% HA level, which is great. That gives me 3.65 days of downtime per year. You really have to place this question to your customer and find a realistic answer. What is his real requirements? And this is actually trickier than it sounds, because behind this HA level, you have all sorts of variables such as what is truly important in my business, what are the systems that are critical, which systems are not critical. And once you start, especially in large organizations where you have a lot of stakeholders deciding what is important and what isn't, it could take quite a long time. Usually somebody just gives up and says, fine, we'll give you the 5 nines. But if you have the energy and the resources, place the right questions. Try to find out what is truly important in that business and how much downtime can they really, really afford. So yes, I am serious about backup and restore, particularly because the backup and restore functionality in CheckMK is awesome. It works almost, I mean, I haven't had a failure yet, so it works all of the time in my particular case, and it's quick and it's seamless for me. I don't have to stop things, it just goes. There is an issue when your system gets too big. So if you're running hundreds of gigs of monitoring data, because that site is very large, then backup and restore might not be the best solution for an HA setup. It's running a little bit behind me. So here's an example. If you can get an SLA of the 3.5 nines, this gives you 4.5 hours of downtime, 4.3 hours of downtime per year. That's a lot of downtime. If your backup takes 5 minutes to complete, that means that you can restore it in a little bit longer than that, let's say 15, 20 minutes, in the worst of cases. That gives you enough time to handle that SLA. And there's 2 metrics or 2 variables that I borrowed from disaster recovery concept, which is basically your RTO, your restore time objective. And basically this gives me the allowed downtime. How much downtime can you really afford? In this case, we've already answered it. You've given me 4.5 hours per year. And then the next metric I need to look at is the restore point objective. How much data can you lose? Will your business be affected if you lose 24 hours of the last monitoring data? If you can handle 24 hours, that means that I can take 1 backup a day, and that should be enough. So I recommend for everyone to take a look at the backup and restore. It can be easily automated, easily scripted, and it will deliver the results that you want if you have a more relaxed SLA. Now, before I get to what I really believe is the solution you should be looking at always, are some other solutions. Now, these are for the typically technically inclined people that want to do things more manually or have more control over what they're doing. I think you need a more relaxed HA level here. You need to have at least an hour to play with to get some of these working. But I've personally played with ZFS. I've been playing with it on Unix for quite a long time. I don't know if you're aware, but you can now run, or you've been able to run Linux binaries inside of a Solaris zone, the Lumos project. And this is pretty great because it comes natively with ZFS, which means that you can just snapshot your entire system, your OMD server, and you can send and receive that little guy to different nodes. And you can also do this incrementally. So I recommend, if you haven't checked this out, look at it. I've got friends working at Netflix that are now saying that ZFS is in production, running on their system, doing really, really large amounts of work, whatever they do there, streaming movies. So I'm inclined to take them seriously on this. rsync is another good option. You just copy the data over from one server to the other. There's a caveat here. You have to make sure that your user IDs and group IDs are the same. Install the RPMs on both systems, create the users, make sure you've got the right user IDs, group IDs, and then just let rsync do its thing. You will have some downtime unless you script it really well. When one of the nodes fails, doing the switch over, you usually have to bring up an IP address manually, start the OMD service, but you can script these. I wouldn't recommend it. It's not as elegant as Pacemaker or the other solutions, but it is an option. DRBD we already know, and this is one that I've seen and I'm trying to play with myself. Containers are obviously a pretty interesting buzzword, but they actually do resolve some real issues. If you're using Docker and you're running your OMD inside Docker, and you're also running maybe ZFS on Linux or in one of these Solaris type zones, it's very easy to snapshot the entire thing, send it over to another node, and it just comes up seamlessly. So there's many great things you can do here. Also, if you're using shared storage, you can run your containers, have two hypervisors or 2 container hosts, and basically just move that storage from one node to another. let's get off of this and get to what I really wanted to show you. So I've been playing with the CheckMK appliance for maybe 4 or 5 months now, I think, and it's awesome. It's easy. It's the CheckMK that you know and love. It's integrated. It's got all of the BS out of the way. Excuse my French. So it's a completely managed solution, and if what you're looking for is a simple 2-node cluster, an active and a passive one, this is by far the best and easiest solution for you to use. It comes in a virtual appliance, which you can deploy on your favorite virtualization platform, or a hardware appliance, which you can respect our so-called best practice and keep the appliance out of the virtual infrastructure. These are some of the reasons why I highly recommend it. Easy to use. You don't need to understand about resources, how to start, stop synchronizations, how to move resources from one node to the other. It's got a graphical user interface, which is a big plus nowadays. Standardized by the CheckMK guys. So once again, I don't have to understand what's literally happening behind the scenes. And it uses great open source technologies. I think my time is almost running out, so what's the best approach? There really isn't. We haven't found situations where I had to, where the appliance didn't work. So in all of the situations that we've been presented with, and we have some small clients and we have some really, really large clients that are doing deployments of 70, 80,000 hosts as we speak, and they're okay with the appliance. There's no reason for them to do anything else. There have been talks if you need a N+1 type of configuration, so not just an active and a passive, you need more nodes, then going manually might be the best solution. But I haven't hit that wall yet, and like I said, we've seen some really, really large clients using these, and I think the appliance is probably the easiest, quickest way to get off the ground. I do recommend simple, probably because as I age, I realize that, boy, this stuff is tough. So I love using stuff that just works, and the CheckMK appliance has worked for us. And I think this is what you need to think about to get things off the ground. If you can get a relaxed HA level, then you can most likely find a more creative solution than going all out with complex clustering and whatnot. Unfortunately, my time is up, and I think that's all I had to say anyway. Thank you very much. I hope you'll find it useful.
Thanks a lot, Marius. It was very interesting.
Thank you, Matthias.
And have a nice lunch. This year we have arranged lunch directly here and not at the restaurant like last year, simply because the restaurant is now all for us. Not enough space for so many people. So have a nice meal, have a nice break.